So now that we know what all these permissions actually mean, how do we go about changing them? In fact, can we change them? Well, yes, they're our files and they're our permissions, so yes, we can change them. That's the whole point. So let's have a look at that. There is a program used to change these permissions, and I'm talking about the R's, the W's and the X's, and that is the program called chmod. Chmod is short for change mode. Chmod's a reasonably complex program. It does take a little bit of getting used to. There are two methods of using chmod. First is called symbolic mode and the second is called numeric mode. They both achieve the same thing but in slightly different methodologies. No matter which one you use, they all look like this. You type in chmod, the name of the program chmod, followed by the permissions that you wish to set in either symbolic or numeric notation, then followed by the file name or file names that you wish to modify the permissions for. And depending on whether you've chosen symbolic or numeric mode, that will just simply alter the way that you specify the permissions. Everything else will be the same. I'll show you examples of those in a second, but I'll just mention that symbolic mode is the mode that's mainly used by beginners. It's probably the easiest mode to remember, probably the easiest one to learn. But it will only take you a few goes of using chmod to get a bit sick of how long-winded symbolic mode is and move on to the numeric mode. That's for people who are comfortable with chmod. Anyway, I'm going to show you both of them. So let's look at that now. Let's look at symbolic mode. In symbolic mode, the permissions that you need to specify are done using letters. As follows, here's some examples. We might type in chmod and then U plus W of any given file. Now, U in this case means the owner or the user. U is short for user, but in this case means the owner. The owner, we're going to add W permission. So we're going to add write permission for the owner. So we're going to give ourselves write permission. Here's another one, chmod G minus R of file 1, which would mean minus means take away, so take away read permission for the group. As you can see, it's pretty easy to get your head around this. So let's see a list of all the various different letters available. There's actually a fair few more than these, but these are the most common. These are the ones that you're going to use on a day-to-day basis. The first of the three things you need to specify is who is getting the permissions. Is it the owner, the group, or everybody else, or all three? And you specify those by using the letters U, G, O, or A, as you can see in the table there. Then you specify an action, add the permission, remove the permission, or set that permission. Now what the set that permission means is if you say U equals W, that means that for the user only, we're going to set the W permission, but that's going to be all we set. The read and execute permissions, the other two permissions are turned off. So in other words, it sets W and only W for the user. That's the U equals W. And finally the permissions, well, they're pretty straightforward, RWX, as you already know. So given that table, you should be able to pretty much specify anything you like. To make it easy for you, they offer multiple permissions specifying in the same command, like the following. These are comma separated. Sets of permissions are comma separated, but there's no space before or after the comma. So UO plus W would give the owner and others write permission. Then the comma means I'm about to specify another set of permissions. Take away read and execute permission for the user. If you use chmod in that way, you cut down on the number of times you have to run the chmod command. Nevertheless, setting all 9 permissions can still be quite time-consuming using symbolic mode. So I'd like to show you most experienced Unix users' preferred way of using chmod, and that is using numeric mode. In numeric mode, all permissions are specified by using 3 digits or 3 numbers. So instead of typing in U plus W, O minus R or whatever it is, you type in 3 digits, and that specifies all the permissions in one hit. So 3 simple digits and you've set all 9 permissions. So how does that magic happen? Well, you have to remember, and this is the only thing that you have to kind of keep in mind, that R is equal to 4, W is equal to 2, and X is equal to 1. Why are they equal to those things? Well, you don't need to worry about that. You just need to remember it. So let's say then for the group, if you wanted the group to be, say, read permission and execute permission, you would add the two numbers together. Read is 4, execute's 1, so read and execute is 5. And because that was for the group, the center digit of the 3 digits that we're about to type in will be 5. Let's see some full worked examples. Chmod 640 of a file, and if you did an ls-l after you ran that command, you'd find rw-r-. Why is that? Well, you've given 6 for the owner, and 6 is a combination of r plus w. 6 is obviously equal to 4 plus 2. So the owner gets r and w, but they don't get the x. The group gets a 4, which is obviously just an r and not a w or an x, while everybody else gets 0, which is nothing, of course. Another example, chmod 070. Now, the 7 is obviously the one for the group, so the group gets everything r, w, and x, because 7 is a combination of 4, 2, and 1 all added together. Nobody else gets any permissions at all. When you get the hang of this, it's actually really simple. You start doing the numbers in your head, and you can type in a chmod command very simply. Now, getting used to all the numbers isn't really as hard as it looks. There are actually hundreds of legal combinations, 512 of them to be precise, but there aren't all that many of those combinations that are used commonly. I'll just show you a table of common ones. For data files, for example, where you don't need to make them executable, you really just need to make things like 444, read permission for everybody, or 666, which is fully read-writable for everybody, or somewhere in between, perhaps 664, which is readable and writable by you and the group, but only readable to everybody else, and so on. Now, if the file is a program, then you obviously need to worry about the executable part as well. So who do you want to make it executable for? 750 would allow you, the owner, and the group to execute the file, but nobody else. And of course 777 is full permissions. Anybody can read the file, write the file, or execute the file. That's not used that often. And directories, as I say, the only one to be really careful about with directories is the W. Be very, very careful whom you give write permission to the directory for. The R's and the X's are not too important. If you're concerned about people seeing even what files you have in a given directory, they obviously can't open the files unless you give them permissions over those files as well, but they won't even be able to see the names of the files if you take away the R permission, the read permission, on a given directory. So let's have a look at some examples of that. Here's files in my directory again. Now that another.txt, I might want to make that readable and writable by me, readable by my group, and nothing by all other people. So I start with a chmod, and I say readable and writable by me. That's 4 plus 2, which equals 6. Readable by the group means, well, read is 4, and nothing, 0 for everybody else. So that was for another.txt. Now you can see, just before I do another long listing, you can see another.txt has got 0 permissions at the moment. Let's have a look at what it has now. Now you can see up here that it has those permissions. Now subdir1, I might want to turn off the R and the X permission for everybody else. I say, right, I don't want people to be able to see or go into that particular directory. How would I do that? Well, using symbolic mode, I would probably say chmod O-RX for subdir1, or, well, that's obviously done it now. I'll just check that, ls-l, and again you can see those bits have been turned off, or I could have done chmod 750 for subdir1, like that. Press enter, and of course it makes absolutely no difference at all. ls-l, and there it is exactly as it was before. So that's a good summary of how chmod is used.